The broadcast is now starting. All attendees are in listen-only mode.
A warm welcome to Sporty's webinar on flying the Garmin GFC 500 Autopilot. I'm JC Merrill from Sporty's Pilot Shop, and I'll be serving as your facilitator for the evening. On behalf of Sporty's, we appreciate you joining the presentation. Also, a big thank you to Sporty's Pilot Shop for sponsorship of our free webinar series. We're very pleased to welcome from the Garmin Aviation Training Team, Mr. Matt Clark and Mr. Gabe Parkinson, who will be delivering our program and also answering your questions on the GFC 500. Garmin, always bringing innovation and value to aviation, took the industry by storm when it introduced the low-cost yet sophisticated GFC 500 Autopilot, and it's quickly become a favorite in the aftermarket autopilot market for light GA aircraft. Before we get started, a few quick reminders during the presentation. Please feel free to submit questions via the webinar software, and we'll answer those as the presentation moves along and at the conclusion. We are recording the presentation, so no need to worry if you miss a slide or have to step away, as we'll have the recording posted to Sporty's YouTube channel and in our webinar archive at sportys.com/webinars for future viewing. So I'm now pleased to welcome Mr. Matt Clark from Garmin.
Hey, good evening. Thanks for having me back on, JC. Glad to be back with you guys again. Tonight, we're going to be talking about the GFC 500 AFCS, but before we go on, a little bit about myself. As you said, my name is Matt Clark. I am one of the pilot trainers here at Garmin. I've been with the training team for about the last 2.5 years. Prior to that, I actually worked with our product support team. So anybody out there answering data, called in, asking database questions, usage questions from everything from Garmin Pilot to through the G5000, there's a decent chance you may have talked to me through the phone, or if anybody's come to our classes, either that over at Oshkosh or here in Olathe around the country, you may have seen me there. But very, very glad to be here with you guys again. Moving on here. There we go. Tonight, as we said, we're talking about specifically the GFC 500. Anybody out there that's wanting more information on the GFC 600, go back. We did a webinar here with Sporty's back in February where we covered specifically the 600. It's going to be very similar to what we're covering tonight, but that one is saved over on their YouTube site, so that's a great resource for anybody flying that system. Other thing we're going to be addressing, we're not addressing tonight, is if your aircraft is covered under our STC or not. That information is available through Garmin.com through the GFC 500 page there. But we'll talk a little bit about that towards the very end of this presentation. So tonight we're going to be talking basic system components, layouts, what are the different options that are available with the GFC 500. And then get into more of the operational side of things. Different statuses, different enunciations that we're going to see or expect to see. Go through an in-depth discussion on both the lateral and vertical modes that are available through the 500. Decent discussion here on our electronic stability and protection. What's the system going to do to help keep us in a safe and protected envelope? We'll go through a few abnormal operations. We're not going to go through everything, but we're going to go through some of the big items on there, so at least you have an idea. If something goes wrong with the system, how do we know it, how do we correct it, and how can we move on? And then the last section will actually be a flight scenario where we'll start from the ground, working everything through takeoff, en route climb, en route phase, VNAV descent if you have a GTN, as well as into the approach phase of flight, and how we can use the autopilot, how it's going to work for us throughout the entire system, or through the entire flight. As JC said, I do have my supervisor here with me. If you go in and hit the questions icon there, or the questions box, we will try to answer as many questions as we possibly can during this. And then towards the end of the webinar, we will have, if there's any good common questions, we'll address a couple ones at the very, very end. If you have a question that does not get answered tonight, we want to get that question answered for you. So down at aviationtraining.webinar@garmin.com, comes specifically to me and a couple of my colleagues. If you don't get it answered, please email us. We will have that email address up in the upper right-hand corner on every slide. So if you miss it on here, don't worry about it. There's plenty of places to go find that guy. But idea is we want your questions answered if we can help it. So moving forward, the GFC 500. So we're going to start into the system components and layout. What are the different line replaceable units? What are the different pieces of equipment that are going to be installed in the aircraft? How's it all going to work together? So we're going to start off here with the G5 flight instruments. This is one of the basic pieces of equipment you're going to potentially need in the aircraft there. Fits in your standard 3 1/8 cutout. It does have a pretty nice LCD display. It does have the ability to have its own GPS. It does have its own built-in ADAHRS. That's the important key for us on the GFC 500. The AHRS source from the G5 is what's driving the GFC 500. So it's not dependent on any other piece of equipment. It's its own AHRS. And then you can kind of see on the back of this guy, there is an optional backup battery. And that battery itself is going to last for a minimum of 4 hours. So if you lose your aircraft power, the electrical system dies on you, the G5 will continue to run. A lot of people wind up putting a second G5 in there. The flight school I teach out of, this is what we have in every one of our aircraft. We're running dual G5s, where we have the top one as an attitude indicator, and we have the bottom one as an HSI. It's a really, really awesome system. The second G5 acts not only as an HSI, but can act as a redundant attitude indicator in case our primary AI fails. So a lot of extra redundancy there. For when we get into the scenario, we're going to focus mainly on the G5. It really doesn't change anything operationally, whether we have 1 or 2 G5s. Just keep that in mind there. Another optional piece of equipment here is if anybody out there is running our G3X Touch system. Both the G3X Touch as well as the G5 can serve as the attitude source for the GFC 500. So if you had an experimental or you had a certified aircraft, but it's VFR only, and you decided not to put the G5 in, but you had a G3X Touch, you're still okay. It still provides that same AHRS information to the GFC 500. Both will display the flight director as well as the autopilot enunciations. We're going to get more detail on that a little bit later. And then if you're running both G5 and our G3X Touch, you have the option, it has the automatic baro sync as well as that bidirectional sync, the heady bug, altitude bugs, and our airspeed bugs. So you change it on one, it modifies it automatically on that other display. Another required piece of equipment for the 500 is the GMC 507, the controller you see in front of you there. If you look at any other Garmin mode controller, they tend to all look fairly similar to each other. In this case, we have our lateral mode selections on the left. You've got your autopilot engagement sections, your level mode, flight director, so on and so forth in the middle. And you have your vertical mode selections, your vertical speed, altitude hold, indicated airspeed modes, all that on the right-hand side. This is going to be, especially when you look at the G5, it's the same spot on the enunciation-wise, you'll see it in the same spot that you see it on the controller. So that makes life a little bit simpler there. And then a very, very critical piece of equipment for us on this are GSA-28, in this case we're calling them our smart servos. These do have microprocessors in the actual servos itself. So unlike, say, a GFC 600 or some other autopilots where that's where the brains are, in a single box, the brains for this is actually spread out between the G5, the mode controller, as well as the independent servos here. These are brushless DC motors. They have their electronic torque and speed sensing, so it can drive that autopilot to certain angles. It can do it very, very smoothly, very, very accurately. The fact that it does not have that slip catch means you've got greater improved performance, and the one everybody likes, the reduced maintenance costs. So as the life of the aircraft goes, you're going to be spending less money maintaining the system. And it's very, very smooth when it's actually flying. In a lot of cases, it's hard. The autopilot can fly better than I can fly the aircraft, which is always a good thing. Layout-wise itself, at very minimum, we need a G5 flight instrument, you need a GMC 507, the mode controller, and you're going to have a pitch and a roll servo. Bare basic system here. One that I think a lot of people are going with, one I would recommend, is the GMU11. It's an optional magnetometer, hooks up to the G5. That's going to provide our heading information over to there. A lot of times those are either mounted over in one of the wingtips or up in the tail, somewhere away from electronic interference. If you're using a single G5, this is an optional. If you have a DGHSI G5, then this piece of equipment is going to be required. We'll get into a little bit later what different enunciations you see if you're running the magnetometer versus if you're not, but we'll come over to that here in a bit. We do have the option for a pitch trim. This gives us automatic pitch trim. The system will automatically trim the aircraft out as needed, as well as providing us a manual electric trim that we can mount a switch over on the yoke to manually adjust that. You can operate with a fourth servo, which is going to be your yaw damper. This just says up there, minimizes your yaw oscillations, maintaining coordinated flight just a little bit better. Some aircraft may want that, some aircraft may not. Just all depends on what you want to install in the aircraft and go from there. Another common one here is going to be our GAD29B. This is our interface box. So if you're running a standalone VHF nav, or in this case here, you're running a GNS 430 or GNS 530 WAAS, you can have that interfaced to the GAD29, then interfaced into the GFC 507. So you can fly those turn anticipation legs, you can fly the nav courses, approaches, everything that the GPS is going to send out. Also going to work if you're going to go more of the full capabilities of the system, you're probably going to include a GTN or GTN 750, GTN 650s. The GTN series will be required as we get into our vertical navigation, but we'll talk about that here in a bit. And we can also link this to one of our flight displays. We've already talked that you can link this up with the G3X system. You can also have this interfaced with a G500 or a G500 TXI that we see here. So you can get your enunciation on there. You can set your bug selections, your heading, your altitudes. You can do it from the display, or you can do it from the mode controller. Either way, it's going to work the same for you. So very quick rundown on basic systems. Now we're going to go into more the AFCS enunciations. What happens when we press a button? Generally speaking, when you press a button on our mode controller, you always want to verify that that enunciation is showing, that the autopilot is doing what you think it should be doing. So let's take a look. For the case here, we're going to kind of focus on the G5. The same enunciations are going to show on the TXIs or G500, 600s, as well as our G3X. But for the sake of this presentation, we're focusing on the G5 tonight. So right in the center, you'll see the magenta bars. That is your flight director. Don't get confused with the flight director being the autopilot. They're not. The flight director is giving us the guidance laterally, vertically as we're flying through, but can be activated independently of the autopilot. We'll come back to that here in just a second. Up at the top are where our mode enunciations are going to be. On the left-hand side there are our lateral mode enunciations. So whether it's you're following a heading mode, like as we are in here, we're following what our heading bug is set to, whether it's track mode, if you don't have a magnetometer, you're on a VOR, localizer, GPS course, whatever course we're following, that's the enunciation we're going to see up there. In the center is our autopilot engagement. Notice how it says AP and YD. So our autopilot's on and our yaw damper is engaged as well. On the right-hand side is our vertical mode enunciation. In this case, we're an altitude hold of 3,000 feet. But if we're climbing, if we're in an indicated airspeed mode, we're in a vertical speed descent, we're on a VNAV profile, or we've coupled to a GPS or an ILS approach, you will see all the vertical enunciations on that side. Now, with it being a Garmin system, there's a lot of similarities from display to display, from autopilot to autopilot. For Garmin systems, anything that is green is an active mode. That is what the autopilot is doing now. Anything that's white is an armed mode. So take a look at either that G3X, maybe my mouse on here, this G3X guy, or underneath it, the G5 flight instrument. We can see that for the G3X, altitude select is armed, versus on the G5, we see GPS is armed, our lateral look. So green is active, white is armed. And if you happen to see any sort of a yellow, in this case, we're showing an AP. If you hit the AP disconnect on your yoke or stick, or if you hit the AP button on the mode controller, you'll see AP start flashing yellow. That means something's disengaged. Or if you see it on a mode, that means a mode dropped for some reason. Now, you'll hear me say this time and time again, and I cannot stress it enough. Always, always, always verify what your active and your armed modes are. Never let an autopilot do or take you somewhere you don't want it to go. I referenced a CJ crash that was up in Cleveland a few years ago. Pilot was trained upon takeoff to turn the autopilot on. So unfortunately, he had his whole family with him. Takes off, thought he pressed the button, nothing engaged. He didn't verify what was active, what was armed. So he assumed the autopilot was flying him somewhere when it wasn't. At one point, blew through a speed restriction and altitude constraints, and at some point, the black box had him pegged at over 60 degrees of bank with 30 to 40 degrees of nose down by the time he impacted the ground. Unfortunately, that's an accident where everybody perished on board, but it's one that could have been very easily prevented. Had we simply pressed the button and then verify what the system is going to do, what the active and armed statuses are, whole crash could have been avoided. So keep that in mind. Always verify your active and armed modes. So moving on from there, you're on the autopilot controller itself, the mode controller here. We're going to break down the separate sections a little bit more. So in the very center, we talked about earlier, is the autopilot engagement section. The first and foremost is the AP button. When you press the autopilot button, your flight director is automatically going to come on, and the system is going to go into a lateral roll mode, and it's going to go into a vertical pitch mode. These are the two default modes. As we like to teach, if you see roll or you see pitch, most likely we've done something wrong. We need to get out of those modes. We're most likely going to either be on an altitude hold mode, and laterally we're probably going to be on a heading mode, or we're going to be on some sort of a nav mode. If you're in cruise flight and you see roll and pitch, you probably need to change our modes. The flight director button itself, that can be turned on independently of the autopilot. So if you're wanting to hand fly that approach, but you still want that flight director guidance, then press the flight director. You're still going to press all the lateral and vertical modes like you would normally do, but bear in mind that the servos are not engaged, that you are hand flying the aircraft. The yaw damper button just to the right of the flight director, if you have the yaw damper, as soon as you hit AP, yaw damper should automatically come on. But just like flight director, we can engage that one independently if we want. The last button is that blue button. That is our level button. That's going to command the wings to level, and it's going to command our vertical speed to 0. So if we're flying around and we get ourselves in IMC, we start getting all sorts of disoriented. We're trying to figure out which way's up, which way's down. Worst case scenario, press the level button, get yourself back to level flight, then we can go back and engage in the other modes that we need to. The other nice thing with that level button, the moment I press it, the autopilot will automatically turn on. So if I'm flying around and I do get that inadvertent IMC, I've been hand flying the aircraft, all I need to do is hit level. Now the aircraft is leveled out. Zero vertical speed, wings level, and we're still in good shape. Another enunciation I do like to point out, for some of those that fly with the G1000, certain airframes will do this, is another way to tell if our autopilot is turned on versus if it's turned off. Now notice the picture I have up here, this is a good indication that our flight director's turned on. I see the magenta bars up there, but notice how they're kind of hollowed out. They're not filled in magenta, it's a darker magenta in the middle. This is an indication that yes, flight director's on, but the servos are not engaged. I'm still hand flying the aircraft. Versus the moment I turn the AP on, I press the AP button. Now flight director still stays on, but notice how those bars fill in. Now my autopilot's on. We like to say with instrument flying, what's the primary fundamental of instrument flying? It's cross-check, cross-check, cross-check. Well, this is a great way to cross-check that. With the autopilot on, flight director bars are filled in, and the AP enunciation at the top of the G5 or your flight display will show. Going over to the lateral mode selection, you're going to see first and foremost you have the heading and track knob. So if we're flying a heading, instead of going over the G5, we'll show that here in a second, we can simply rotate that knob, adjust our heading bug as we need to, or if you simply press in on that knob, that'll sync to your current heading. If you don't have a magnetometer, you're now going to be directing your track. So you'll be pressing the track button, but you're still going to use that knob to set the desired track, the desired ground track, or press the knob in, send it up to your current track. Nav mode, probably I say heading mode and nav mode, even approach mode. They're all the most commonly used buttons on here. Your nav mode is what you're going to do to follow GPS course guidance. It's also going to be what you're going to use to track to or from a VOR. You can track to or from a localizer, any sort of nav course we can use nav mode and follow. And the last button there is our approach mode. This is what's going to arm if we're on a heading to an intercept. So we're heading intercepting a localizer or intercepting a final approach course on an approach. We can hit that mode. It'll also automatically arm the appropriate vertical mode. So if you are flying an ILS, you are flying that GPS approach, when you hit approach, it will arm that appropriate vertical mode. Now, for those who are wondering, what is the difference between heading mode and what's the difference between track mode? Generally speaking, if you have that optional magnetometer, 9 out of 10 times, you're going to use heading. When ATC says fly heading 090, you're going to go hit the heading bug, you're going to set 090, and you're going to fly a specified heading. For those that don't, the heading button is not going to do anything for us. So we're going to use the track button. And that is flying a GPS track, a specified GPS ground track. The big difference enunciation-wise, the top one up here is a white enunciation. That means you're flying with a magnetometer versus the bottom picture, you see the magenta. It means you're following a specified GPS ground track. Now you can go back or forth on this if you want. If you have a heading but you want to fly a specified ground track, fantastic. Hit the track button, specify the course, and you will follow that ground track, regardless of what the winds are doing for you. On the right side of this are all of our vertical mode selections. So the first there, as we said, when you turn the autopilot on, you're going to go automatically into a pitch mode. And the enunciation will show PIT on the right side. We can adjust that aircraft pitch with that up and down wheel. But that same up and down wheel will also modify our indicated airspeed, also be used to adjust our vertical speed. The one I don't really talk about too much on here is that ALT button. That is our altitude hold button. Pressing that ALT will automatically capture the current altitude we are at. Now, unlike the GFC 700, when you see that in the G1000 system, when you hit altitude hold there, you're stuck at that altitude. If you need to change, if you need to go higher, you need to go lower, you have to kick into a different vertical mode to change that. With the GFC 500, we can actually modify that altitude, I want to say plus or minus a couple hundred feet, using that up and down wheel. So if we hit altitude hold and I wanted to be at 3,000, but I'm at 3,040 feet, I can use that down wheel and I can set 3,000 as my altitude that I want to sit at. And the system will adjust down for me. Two commonly used modes here. The first one we'll talk about is that IAS, your indicated airspeed mode. This is a very, very useful mode. I like using this mode on a climb out. You can set your specified climb, whether it's VY or if you have a specific climb cruise airspeed. I fly one of our Cirrus out here, and traditionally I want to be at least 120 knots or greater if I'm in a prolonged climb for better engine cooling. So I can hit IAS, and I can use that up and down wheel, and I can very accurately set the specific speed I want to fly up at. The advantage of IAS over vertical speed up is no matter what happens, the aircraft is going to maintain that indicated airspeed. It's going to do what it needs to do to maintain it. Whereas vertical speed, as you go higher and higher, your vertical speed's probably going to start dropping off. So because of that, IAS is a very, very useful one in a climb. Vertical speed, that bottom button in the center, that's what we're going to use. I like using that for a descent. So we'll use that in conjunction with our altitude select wheel, and then we can use that in conjunction with that up and down wheel. Now, pressing either IAS or vertical speed will by default go to what you're flying at now. So IAS wise, you're on a climb, you set your flying VY. The moment you hit IAS, that's the airspeed that's going to peg, and I can adjust it from there. If I'm in a descent and I hit vertical speed, then it's going to default to what I'm doing that second. I can use that up and down wheel, and I can set in hundreds of feet per minute very accurately what I want to descend at. The VNAV button on there, that is only going to apply if you're running a GTN 650, GTN 750, anything with our any option on the GTN series with software 6.51 or higher. Now, currently, we are running GTN version 6.62. So if you're running 6.51 or higher, you have the option to do a VNAV descent. You create the VNAV profile in your GTN, and then you're able to arm the VNAV and track that vertical nav path all the way down. We'll talk about that here when we get more to the scenario, but that's a very, very useful feature for us. The last one is the knob up there. That's our altitude select knob. We're going to use that in conjunction with the indicated airspeed mode, vertical speed mode, as well as our vertical nav modes. When we start thinking about a climb or descent, the first thing you're going to do pilot action wise is to set your altitude with that altitude select knob and then engage the appropriate vertical mode, whether you're going up or down. So we'll definitely use that guy quite a bit. Now, the GMC 507 is probably going to be the preferred way to set heading and altitude, but you can do this with a G5 itself. You can see on the picture there, if I press in on the knob on the G5, you'll see a menu bar pop up, and then I can scroll over, I can set a heading, I can set an altitude. It's more button pressing in the long run. It's definitely going to be easier to do that off the GMC 507, but this is an option there. Now for those running a G500, running TXI or G3X, the bug selections on there will transfer to the GFC 500. So in that case, you can use either the G5, you can use the 507, the mode controller on the bottom, or you can use your flight display. Is there a right way? Is there a wrong way? Absolutely not. Whatever is going to be the easiest for you in flight. That's the key. All right, we're going to move along here, and we're going to talk a little bit about our electronic stability and protection. What is it doing? What's it doing for us? How is it trying to keep us safe? And where is it going to work? Where is it not going to work? Essentially, ESP, or electronic stability and protection, provides a flight envelope for us. Corrects for pitch, bank, airspeed, and guides us back into a protective envelope. They don't want us going too extreme on the bank angle. They don't want us pitching up too high. They don't want us going too fast. And at the same point, they don't want us going too slow. So keep us in a nice, comfortable, safe envelope that ought to keep us protected. And especially if we get into a need for an IMC, if we get disoriented, the system is going to help give us a little extra guidance there. The system automatically arms at 500 feet AGL. So we don't need to worry about, are we arming it? Are we turning it off? The system automatically arms at 500 AGL and will disarm below 200 AGL. So as we break out on an approach, I don't necessarily want ESP trying to kick in as I'm coming into flare. The system will automatically take care of that. It will disable itself or disarm itself, and down we go. So for our roll or the bank protection here, it's really discouraging bank beyond 45 degrees. On the picture to the left, we can see the dual green hash marks. This is to protect us when we are hand flying the aircraft. The moment you turn the autopilot on, those green hash marks are going to go away. The system's not going to go that extreme of a bank angle with us anyway. But if we're hand flying, you'll automatically see those green marks appear. As we roll past that 45 degrees, notice what happens. The yellow hash marks right there and right down there are going to go down to 30 degrees of bank. It's guiding us back into a protective envelope. The further into that past that 45 that we try to roll, the greater the servos are going to fight against us, trying to get us back into that, inside that 30-degree area. Now we'll come back to it later. I already know there's a couple questions out there. What if I'm doing steep turns? Hey, this is a training aircraft. I'm trying to do that maneuver and I don't want ESP kicking in. We'll talk about how we can get around this here in just a little bit. For pitch, the bank and roll, that's a pretty common one across all airframes. The pitch up or pitch down is going to vary from airframe to airframe. So this is a good case where you need to read your AFMS, your Aircraft Flight Manual supplement, for these specifics. As a good example here, the Piper Warriors, the PA-28, the Warriors Archers, and so on, as well as say the Cessna 210s, just as a couple of quick examples, have a pitch up of +20 and a pitch down of -15. Anything outside of that, the servos are going to kick in and they're going to increase that pitch until we get back into the safe, protected environment. So always reference back to the AFMS. Now what will happen here, if we're in there, we're hand flying the aircraft, and this is that use case here. We're trying to do that steep turn, but I decided not to turn ESP off. If you're in ESP, if it's trying to kick you back into that protected envelope, and you're there and you're outside of that envelope for 10 seconds in a 20-second time frame, the system itself is automatically going to put us into level mode. So if we inadvertently we're getting ourselves into a steep spiral and we didn't realize it, we're outside of our proper engagement zone there, or outside of our ESP protected envelope, this is where this system will really come in handy here. You'll get an OR alert saying engage in autopilot. You'll see your lateral and your vertical mode selection both go to LVL, or level. So it'll automatically kick you on there. Now this is with the autopilot off. We didn't turn it on, we were still hand flying, but it'll automatically engage the autopilot to keep us safe and protected. Now the level mode through ESP will automatically arm above 2000 AGL, and descending will disarm at 1500 AGL. So as you start coming down lower, now we're more on our own to maintain that proper flight. Other options that the system does for us, we have high speed protection and we have low speed protection. High speed will keep pitching the nose up to prevent us going beyond VME, trying to keep us from overspeeding the aircraft. And our low speed protection is going to continue to lower the nose to prevent us from stalling. So I've heard this with other autopilots or asked other questions. Will the autopilot let me stall? In this case, no. We're going to keep lowering that nose. We don't want you to stall. Now for that low speed protection, we do need either a Garmin primary flight display, or we need a GTN with a valid terrain database. We have to have something to reference off of. Big important on here, this is automatically inhibited below 200 AGL. So as we break out on our approach, as we start coming into our landing phase, start breaking into the flare, I don't want ESP lowering the nose on me. That could be a little bad. So we're going to go ahead and inhibit it. That way we can slow the aircraft down to the appropriate landing speed. So overspeed protection as well as underspeed protection work while the autopilot is engaged. Your ESP lateral and vertical modes work when autopilot's off. Overspeed and underspeed work when the autopilot is on. As we said, this is going to pitch the nose up, keeping us from going past VNE. If it looks like we are going to exceed that, you're going to get a max speed display. You'll see it there in yellow on right above your airspeed tape. Your vertical mode is going to change to an indicated airspeed mode, so it's going to pitch up to maintain a proper airspeed, or an airspeed that's not going to exceed VNE. And whatever mode we had armed previously, or active previously, I should say, is going to go to armed. Once we get ourselves slowed down, system can come back to level flight, then that mode, the previous mode we had, will become active. So if we were altitude hold, but we just got way, way too fast, IAS would go active and our altitude hold would arm. Underspeed protection, as we said, this is going to discourage you from going below, in this case, stall speed. We don't want to stall the aircraft. Just like overspeed protection, we are going to get a visual alert. We're going to get a min speed here, saying that min speed right above your airspeed tape. The nose is going to pitch down. Same thing as vertical mode. We're going to kick into an IAS, an indicated airspeed mode. And once we get the aircraft slowed down, then it can bring us back up, or not slow down, excuse me. Once we get enough airspeed back, then it can level back out or go back to that previous mode as need be. So big high level here. For pitch and roll protection, the autopilot is not engaged and the aircraft is in the autopilot engagement envelope. So if you're trying to do some real extreme maneuver, you're at a 80-degree angle of bank, you're not going to be able to turn the autopilot on. ESP is not going to kick in there. But if you're within the engagement zone, the pitch and roll protection will kick in automatically. For USP and OSP, the underspeed protection and overspeed, as we said, this is going to work with the autopilot engaged. We need a GPS altitude greater than 200 feet. And once again, the aircraft's in the autopilot engagement envelope. Now, as promised, we're flying along. This is a training aircraft. We're going to do steep turns. We're going to do some maneuver, and I don't want ESP kicking in. I don't want it trying to kick me into level mode. I'm purposely going outside or going into a condition where ESP would normally kick in. There's two ways we can get rid of or disable ESP. First and foremost, press and hold the autopilot disconnect. This is a temporary measure. So if I'm doing that steep turn, but I want ESP to work the rest of the time, I can hold the autopilot disconnect. I can maneuver the aircraft as I need to. The moment I let go, though, ESP is going to try to kick back in. The other option, if I know I'm going to be doing a lot more aggressive maneuvers and I don't want to hold that button down, we can go in and disable ESP. This is a pilot option for us. For the G5, we're going to press the knob on the G5 itself. We're going to roll over to ESP, that option right there, and then we'll press the knob in. Green line means ESP is on. If the green line is off, ESP is off. So that is one way to turn it back off if we don't want it on. For those running the G3X Touch, excuse me, if we hit the autopilot status bar, the actual mode enunciation bar on the G3X Touch display itself, we can also modify our AFCS statuses there as well, our mode selections there. So we press that box on the top of the display, and then we're going to go down and simply tap on ESP itself. Same thing as the G5. If you see the green line on, ESP is on. If the line is not there, if it's off, then ESP is off. Those are quick, easy ways to modify that if we needed to. All right, I'm going to go into a few abnormal operations. Now, here's my caveat up in front here. I'm not going to talk about every single potential abnormal operation. I very highly recommend taking a look at the aircraft flight manual supplement. Take a look at that guy. He's going to go into a lot more detail on what we should do. Generally speaking, if you run into any sort of abnormal operation, the autopilot's doing something that you don't want, it fails, you have a runaway trim, basic idea, grip the controls firmly, disconnect the autopilot, whether it means you pull the circuit breaker, whether it means you hit the AP disconnect, grab the controls, disconnect the autopilot, and hand fly. Never let the autopilot take you somewhere you don't want it to. So with that caveat ahead, let's go into this stuff here. First mode we're going to talk about is if you see a yellow flash. For anybody who's used to flying G1000, it's the same logic here. If you see a yellow flash, in this case, if you manually change a CDI source. I go from GPS and I go over to VLOC. I want to track that VOR or track a localizer. If I manually change it, the mode is going to drop. In this case, we can see that. GPS is in yellow, and it automatically reverted me back to a roll mode. That means it's going to keep my wings level, and that's as far as that's going to go. So for me, if I need to track that other course, then it's up to me to re-engage my nav mode, and that will change that enunciation to the proper course it should be. Another option here, the other time you'll see it, is when you disconnect the autopilot. Whether you hit the AP disconnect on your yoke or stick, or you hit the AP disconnect or the AP button on the GMC 507. In normal AP disconnect, to get a tone, you'll see the yellow flash and that mode enunciation will drop off. Your flight director can still stay active, your heading mode, your altitude and hold, all that can still show the same, but notice how AP is disconnected, it shows yellow, and down on my flight director, I've got those hollow bars. So I know the flight director is good, but I know the servos are not engaged. One I hope you guys never see is an abnormal disconnect. Something happens in the system, something determined that it needed to disconnect. You're going to get a red AP enunciation like you see at the top of the G5, right up there. And you're going to get a continual oral alert. It's going to keep screaming and yelling at you until you acknowledge it. So it means we need to go in and either hit the AP disconnect on the yoke or stick, or we need to go in and actually press the AP disconnect on the GMC 507. A couple other potential potential errors you may see, hopefully you never see, is if you get a red AFCS like you see up there. If you see a red AFCS, it means your autopilot has failed, your flight director is not available. Do not fly with the autopilot at this point, it's not going to work for you. Another option you may see is if you see a yellow or the amber AP, but you see a red X. If you see that red X, the amber there, the autopilot's failed, something in there is not working right for us, but the flight director is still available, so we can still use that as additional guidance on the way down. A couple of warnings from the AFMS itself. In flight, do not overpower the autopilot. As we try to overpower it, the trim is going to continue to go in the opposite direction. You get some real large out of trim forces. As I said at the beginning of the section, if you feel that the trim's running away, if something's happening that you don't want, grip the controls firmly, disconnect there at the autopilot, and hand fly. The other pretty big one here, do not re-engage an autopilot or use your electric trim until the cause of the malfunction has been corrected out. So if you don't figure out the cause of it and you try to re-engage, you could put yourself back into the same issue you just got yourself out of. So, word of warning there. All right, so our last little section here, we're going to kind of run through a little flight scenario, taking it from on the ground, taking off, and through our climb, through en route, and through a couple different descents, and into an approach phase. How we can use the autopilot, what enunciations we're going to look for. Let's let the system help us do that. Our flight profile for today is going to be through New Century, Kansas here, KIXD, over to St. Louis via the Kayla 3 arrival, Napoleon transition. Quick, easy flight for us there. So we're on the ground at New Century, and these are our instructions. On departure, fly a runway heading, climb and maintain 3,000. Pretty easy instruction for us. I'm going to look at this in two different senses for the sake of this scenario. We're going to say we do not have a takeoff go around button, but I'll comment on there where appropriate. So without having a takeoff button, what we can set our heading bug. So we know in this case they're going to have us take off on runway 18. So we're going to set 180 as our heading, and we can engage heading mode. The moment I hit the heading button, the flight director is going to come on up, and we're going to go into an automatic pitch mode. So we can verify, we see green headings active, and then we'll do the same thing. We're going to set our altitude. I'm going to take my altitude select button there, or wheel. We'll set it up to 3,000 feet, And then we can set our appropriate climb pitch. Remember, pitch is the default mode. The moment the flight director comes on or the autopilot comes on, it goes into a pitch mode. This is about the only time I'd really use a pitch, is to set a specified takeoff pitch. So here, we'll verify pitch mode is active. We see it, it is. And we can see ALTS, Altitude Target Select, is armed, meaning once I get to 3,000 feet, the system's going to go ahead and automatically level me out. Now, for those that have a takeoff go around button or TOGA, what we can do, it's even simpler. All I need to do, I'll set my heading button, I'll pre-select my altitude, and then I can simply press the takeoff button. I'll get a takeoff annunciation. It'll automatically kick my flight director up to an appropriate takeoff pitch attitude, and I don't have to worry about going into a pitch mode. So that is an option for those that have that button installed. So we take off, we're flying our heading, we're pitching the aircraft up, and still same ATC instruction. On departure, fly runway heading, climb maintain 3,000. For the flight manual supplement, once we reach 800 AGL and above your minimum engagement speed, we can engage the autopilot. So I simply need to press the autopilot button. I've already preset my heading, I've pre-selected my altitude. We're fairly simple at this point. Once I'm high enough, I'm going to go ahead and engage IAS mode, indicated airspeed mode. As we said, once I hit IAS, it's going to automatically default to the airspeed I'm currently at. So if I am tracking VY, as we are in this screenshot here, the moment I hit IAS, that's the airspeed it's going to peg to. If I need to adjust it, I can use that up and down wheel, that wheel right in the center. I can use that guy to dial in my appropriate climb speed. As I said at the beginning, once I've done all this, I'm verifying my status. Heading mode's active, autopilot's good. I'm in an IAS mode at 95 knots. I'm in an altitude select, meaning it's going to capture 3,000. As I've said, and you're going to get tired of me saying this, when you press a button on the mode controller, verify the enunciation. All right, next instruction for us. Turn left heading 090, climb and maintain 7,000. Still reasonable instruction. So we're still in a heading mode. So I'm going to take that the heading knob on my controller or through the G5. We're going to dial in 090 as our heading, and the aircraft's going to start rolling, in this case, out to the east. We want to climb maintain 7,000. So I'll take my altitude select knob, I'll roll it up to 7,000. And depending on how fast we get up or how fast that instruction came to us, if we leveled off, then I'll need to re-engage IAS mode, and then we can reset to our desired climb speed. If I'm still in the climb, all I need to do is roll the selector up and it will keep on going. So it depends on the scenario, it depends on the situation we're in. As we've said, always verify your status. So heading's still good, autopilot yaw damper are on, we're still in indicated airspeed mode, we're still at altitude select. The only difference now is we've set it to 7,000, a little bit higher. Our last climb here, go okay, proceed direct to ANX or the Napoleon VOR, climb and maintain 15,000. Very easy to do. Go ahead and set direct to on your navigator, whether it's 430, whether it's a GTN or one of the 2-inch, set your direct to, and then we can engage nav mode. For altitude, we'll reset our altitude select up to 15,000, re-engage IAS if we need to, and then we're going to verify what our AFCS enunciations are. So this time we hit nav and we went into a GPS mode, meaning we are tracking GPS course guidance. Indicated airspeed mode is still what I want to use for the climb. It's still going to take me up there. And we have altitude select, meaning it's going to level me off at 15,000. As we level off, we come up closer. Once we get within 200 feet, altitude select ALTS goes active, as we can see. And then as the aircraft actually reaches 15,000, we go into an altitude hold. I don't have to tell the system to do it. I don't have to pre-arm anything else. the system will automatically transitions me into altitude hold mode. It's simply something we need to monitor as we level off. So these are one of the questions here I get when it comes to VNav. So big things for vertical navigation. You need to have your VNav profile set in your navigator. In this case, this needs to be one of our GTNs. GTN 750, 650, any of the GTN line. We get the instruction here, crossing COOP, descend via the arrival, maintain 7,000. I know there's multiple altitude constraints, multiple altitude restrictions that I need to comply with as I come down. ATC wants me to do that. So as we load the arrival in, I'm going to verify those altitudes are correct in my GTN. And then prior to reaching the top of my descent, I can arm VNav. Now, before we do that, we also need to roll our altitude select down. Good habit pattern here. So they told me to maintain 7,000, so I'm going to roll my altitude selector to 7,000. If there's any altitude constraints in the middle, the autopilot will automatically adjust my flight path as it needs all the way down. So we reset our altitude selector to 7, and we arm VNav. I hit the VNav button on the controller, and as I've said in the past, verify your modes. So we're still at altitude hold at 15,000, but we've got VNav armed, meaning when I hit the top of my descent, the system is automatically going to capture that path and take me down, in this case, to 7,000. 1 minute prior to the top of your descent, you're going to see your VDI, your vertical deviation indicator, in the box there. If you're running a G5 HSI, you'll see it next to your HSI down there. And you'll see a vertical speed target. That is based on the altitudes that you have in the navigator, inside your GTN. So these are great options to look at here as we're coming in. As we capture the path, as we get to the top of our descent, our VDI centers up, and notice what happens to our mode enunciations. VNav is now active, and you're going to see either ALTS or ALTV depending on where we're at. In this case, the aircraft doesn't need to level off. The way the altitude constraints are in the arrival, it doesn't have to level me off. So it's going to take me down, in this case, ALTS to altitude target select at 7,000. If there are any waypoints that the system needs to level us off at due to an altitude constraint, then you'll see ALTV. That is your VNav target altitude. So you'll see those interchangeably as you work down a VNav path. If you do need to level out early, then all we need to do is raise the selector up. The altitude selector will take priority over the altitude in the VNav profile. So if ATC says, number 1, 2, 3, 4, 5, I need you to level off at 10,000. All I need to do is roll my altitude selector up, and that's where it will level me off at. Now we get a little bit closer in. Now we're getting closer into St. Louis. We get a simple instruction. One out in the Midwest we're pretty common with, we're pretty used to out here. Descend and maintain 3,000. Straightforward instruction. First option or first action for us, set your altitude bug. So use that altitude selector, set 3,000 feet. You see the enunciation up on the G5. And then I like to use vertical speed. You can use IAS, you can use any of the modes that you want to try to get down. I like using vertical speed for a descent. So I hit vertical speed. As we said, the moment I press the button, it's going to go to my current vertical speed. Well, if I'm level, it's going to be 0. Well, I need to tell it that we want to go down. So I'm going to use that down, up and down wheel, and I'm going to set the desired vertical speed. On the enunciation itself, I'll see vertical speed, and then I can see the rate. In this case, we've got negative 800 feet per minute down. So you can fine tune for 100 feet per minute increments how fast down, up or down we want to go. The fact that we had 3,000 set initially means once I get to 3,000, I see ALTS armed, that altitude target select, so I know the system's going to level me out at 3,000. And then the last one, we're coming in, we're getting ready for an approach. Could be low IMC, could be less traffic. I want the autopilot to help me. So we get a heading to intercept. They set fly heading 090, to intercept the final approach course, maintain 3000 until established, cleared RNAV 12 right. So we've loaded up the approach, we've got everything active in there, we've hit vectors to final on our navigators, everything's good there. I set heading, so I hit the heading bug, I set that over to 090, I hit the heading bug itself, and I verify that heading is active. And then I'm going to verify that I'm on the proper CDI source. Once cleared, I'm going to arm approach mode. So I hit the APR button, and then I need to verify some stuff here. If I look back up at my status bar, I see a white GPS and I see a white GP. So we're flying on a heading. I'm waiting to intercept the final approach course, in which case it'll start tracking a GPS course inbound. And then on the right-hand side, I see a white GP for glide path, meaning once I intercept the glide path, the system will automatically take me down. This is how I know approach mode is armed. So take a look at that and watch it very closely. As the system intercepts here, our needle, our CDI, right on the G5 there, is about to center up. GPS goes active. And it's going to track that lateral course. And then as my needle starts coming in, we've intercepted, my needles are centered up. My VDI, my vertical deviation indicator, is coming down. And once it centers, glide path becomes active. This is what we want to see. And then we start coming on down. Below 200 AGL, we need to disengage the autopilot. That is per the AFMS, but think about it in simpler terms. You hit minimums, disconnect the autopilot. Now, the one thing I don't talk about is a coupled go around. We do have that capability if you have a TOGA button, that takeoff go around button. If we need to go missed for any reason, I can hit TOGA, takeoff go around. My lateral mode will go to GA, meaning go around. My vertical mode will go to GA, and it'll automatically kick the flight director up to an appropriate go around attitude. Big thing on this, the autopilot stays engaged. The servos are still flying the aircraft. So we hit go around, we clean up the aircraft, gear comes up, flaps come up, get ourselves established and climb. And then all we need to do is re-engage the appropriate lateral mode. So we need to go back into nav, or if a modified missed, go into a heading mode. And if it's a prolonged climb, I'd probably swap back into an IS, or indicated airspeed mode, depending on the situation. So a couple text references, always good references to refer to. If you're running a G500, 600, or a TXI, there are enunciation specific things in there. Take a look at those. If you're running G3X, take a look at that guide. G5 Pilot's Guide for those running just straight up G5s. And the one I recommend, every person running one of our autopilots, read through your AFMS, your flight manual supplement. Take the time and read through it carefully. You'll save yourself a lot of headache in the long run. So a couple other quick items here for a list of supported aircraft, the current aircraft in progress, and the planned aircraft for our future certification can all be found at garmin.com/GFC500 under the supported aircraft tab. I'll tell you everything that's currently out there now. And if your aircraft is not listed on there, we do have a request form. So put the request out there. It's a dynamic list. The more requests for a particular airframe, the higher up the list that aircraft goes. And then we have a separate setup form if you are willing to loan your aircraft to us to be used in that certification. There is a form for that guy. All right, so give me just a second here. I'm going to confer with Gabe, see if there's a couple common questions. We'll answer a couple of those, and that's going to bring us right up to the end of time. So bear with me for just 1 minute. Okay, thank you guys for being patient with me here. So a couple quick questions we had, talking 430, 530s as well as our new, the 2-inch navigators, or GNX 375, the GPS 175, asking, are there any big limitations when it comes to those systems? The big one, and applies for both of those units specifically, is if you're running a 430, 530 WAS or you're running one of the 2-inch, you are going to lose that VNAV capability. It's not going to follow the V path. Yes, I know the 430, 530s, they say it's vertical nav. It's really a vertical calculator. It's not creating a path for us to follow, whereas the GTN does create an actual path to follow all the way down. So very, very good question there. A couple other questions we had. I know one was talking about if you're interfacing with a GF500 or you're running a TXI display, disabling ESP, how's that going to work? We talked G3X. You can go into the AFCS status and turn it off through there. If you're running a G500 or you're running a TXI, you're still going to have a G5 flight instrument that's still providing that AHRS source to the autopilot. So turning ESP off is simply going through the G5 to turn that feature on or off. So very, very good question on that one. Okay. So a couple other big questions there. So if there is a question in there that we did not get to, please email us at aviationtraining.webinar. I'd be more than glad to get back and do some more research for you guys. But I do appreciate everybody listening, and I do believe this will be posted up on YouTube here shortly. But without further ado, that's all I have for everybody tonight. Thank you for your time. Thank you for listening to me.
Well, a big thank you to Garmin Aviation for a great presentation, and thank you for joining. Please check our upcoming webinar schedule at sporties.com/webinars, and we hope to see you again for another future presentation. Safe flying, everybody.